Guys, welcome back to the channel. Working on the Cub Cadet bulldozer, mini bulldozer. All right, I think this is episode 11. Anyway, got a couple things to do here today. I've got to tack up the hood and dash, the hood, dash, and grill riser. This slides all the way forward to the lift tower. And then I need to fabricate another riser, same size, rectangle in the back here to raise the seat up to the same level. So those two things are on tap right now. I'm also, as I do that, I'm going to pull the engine out, and I've got the new engine plate. This is the new engine plate that I cut out. So we'll put this on the engine and go ahead and weld the shelf on the frame. Right now there's just a couple of angle iron pieces tacked there. We'll go ahead and weld them to the frame, mark for the holes in the engine plate, get the engine mounted in its permanent position, or at least temporarily mounted in its permanent position. We'll get some bolts in it. Okay, so that's what we're working on right now. Once we get this platform in place, we'll clamp the dash and the hood and everything back on, just to make sure everything fits okay. And then we'll shift our attention to the controls for the hydro. We'll pull everything back off and work on that. All right, let's lift the engine up. It would help if I took the belts off, wouldn't it? One way to get it off. So I need to make sure I have the pulleys aligned. Using a straight edge on the face of the pulley, line it up with the other pulley. So I got to go back just about a 1/16 of an inch, or not much. All right, that's pretty much dead on right there. To mark the positions for the bolts in the shelf. Okay. Now what I can do is pull the engine, take the plate off, set the plate on there. Drill the holes. So the engine plate sits like that. All right, so I marked the location for the holes, and then this will give me some adjustment capability as well, having the slots here. So we'll mark the actual holes. All right, so those will give us the holes. I'm going to sand some of the paint off of here so we can put a couple of short welds on there. I can bolt the engine plate down. We had this about right there. Got the engine fully mounted now. The pulleys are aligned. It's bolted in. It's in its final position until I have to take it out to do something else. I've decided that this riser frame here for the grill and hood and dash, I'm going to weld it together, but I'm going to bolt it in 3 places to the lower frame. I want to be able to remove it to give me easier access to the engine bolts. It's non-structural. It's simply a cosmetic thing. And the other thing I'm going to do is the riser. I'm going to do the same thing with the riser for the seat. It's going to be a rectangle, going to sit on here, raise the seat up about 3 inches, and I'm just going to build a rectangular frame, weld it up. We'll drill holes through it, and then we'll drill and tap holes in the frame, probably 2, maybe just 4 holes for the seat. Since I've got 3 holes here, planning on 3 holes, 1, 2, 3, just to hold those frames in place. Since they're just cosmetic, or well, maybe not more than cosmetic. They're non-structural in any case, and I would like to be able to remove them. So I'm going to finish doing that, and then that will pretty much wrap up the framework. Then I'll shift my focus to the controls. That's next. I've got the seat riser parts cut out, and we'll tack it together and weld it up. And the plan is to bolt this to the lower frame just with a couple of bolts. It's strictly cosmetic, and I mean it's functional in that it raises the seat, but it's a non-structural member, so that'll be relatively easy to do. I'll probably tack it together, but I won't weld it or attach it until we're finished with the controls. Same with the grill and hood riser. I've just got it sitting here. The plan again is a couple of bolts through it to hold it in place so that it can be removed to improve access to the engine and the engine bolts. And since it's non-structural, that'll be fine. So that's couple of things to do. I've already started design work in Fusion 360 for the parts to build the tensioner. So I think I'll be cutting out at least the pivot point for the frame in the next, within the next day or so. We'll be working on the tensioner. So once we get the tensioner and the controls done, then we're in pretty good shape for the frame. Everything else is just bolt-on grill and hood and dash. It'll take some time to get the controls from the dash to the engine. The dash does have a throttle and choke, cables, and the electrical, the ignition switch, and all that stuff. I have to run all that to the engine for starting and operating the engine. So we're closing in on, completion of the main body of the Dozer. I've ordered spacers for the hubs, waiting for them to come, and I need to order the second drive, sprocket, and some more of the chain. Before I do that though, I want to do a mock-up of the track. So I need to do that before I spend the money on the chain and the other sprocket. So the plan is to cut out a couple of track pads and test the track design out. All right, that's where we are right now. We'll come back when we're working on the controls. Working out the controls for the two hydrostats is, I think, pretty straightforward. Let me draw a picture here. This is, and I'm drawing it as a sector with rotating around a shaft, so this moves back and forth. This is the trunnion. We'll call this the front of the dozer, and then there's a trunnion on the back hydro. And both of these hydros face the same direction. The control of the trunnion is back and forth. When you push this trunnion back, the wheel, and I'll draw it over here, goes forward, so toward the front of the tractor. So that would, pushing this trunnion back drives the wheel in the forward direction. Pushing this trunnion back drives the other wheel in the front direction. And of course, the opposite is true. If you pull it forward, the wheels go in the opposite direction. So what we want to do is control these two hydros with a pair of levers. So if let's draw them again. If we have two levers, and they're going to be side by side, but I'm going to draw one, in front of the other here. If we have these levers pivot, around a central point, you pull this lever back, then the bottom goes forward. If it's connected to the trunnion, like that, then it pulls the trunnion forward, which makes the wheels go backwards. And you attach this one to this trunnion. If you pull the lever back, the bottom goes forward. It pushes this trunnion forward, which causes the wheels to go backwards. So pulling the handles back causes the wheels to go backwards. If you push them forward, draw that same picture. With the two trunnions, you push the levers forward, then connect these two. The trunnion goes backwards. The trunnion goes backwards, so the wheels go forward. It may be counterintuitive that when you push the trunnions backwards, the wheels go forward, but that's just how the hydrostats are set up. So in order to have, a central pivot point for two levers which are side by side, here they're front to back, so if you have a plan view, that is from above, you want the levers to be side by side. So you have your hydro here with the trunnion on the side of it, and the other hydro here with the trunnion on the side of it. And you want this lever to go backwards and forwards, and this is looking from the top down, and this lever to go backwards and forwards. So in order to get those two side by side, pivot, and have both of the controls, they need to run, from this pivot point back to this trunnion and then to this trunnion. And they're both on the same side of the tractor, so it's not like one's on one side, one's on the other. They're both on the same side because both hydros face in the same direction. In order to do this, one easy way to do it is if you have a shaft, and this is looking, say looking this direction. You have a shaft, and you put a lever on the shaft that turns the shaft, and you have a lever off the bottom of the shaft that is your control. So this is the handle, and then this is what controls, and this shaft, you know, pivots this way. And then what you do is you put a sleeve over the shaft here, and you put another control off that sleeve and the other handle off that sleeve. So now you have one shaft, you have a sleeve over it, you have a control here and a control here, a handle here and a handle here. So this one controls this one controls this one, and they're both on the same side. So your shaft would run across the tractor, and both of your control arms would be, you know, on this side of the tractor. So this is how we're going to build the control mechanism. Now there's a couple other issues that we need to address, and one is either create friction in this control so that it stays where you put it, or create spring returns to neutral. Spring return to neutral is a lot more complicated than just a friction control. The hydros on the Cub Cadet tractors have friction in the control, and they have a foot pedal which returns it to neutral. So if in a panic situation, you step on the foot pedal and it brings the hydro to neutral and stops. It's possible that we could do a foot control that would bring everything to neutral, and we could do friction here. It's not ideal to just have friction, because whatever, I mean, it's like a dead man switch. If you don't have a dead man, that is, when you let go of it, the tractor should stop. No, you should have to hold it in position for the tractor to move. I mean, that's clearly not how the Cub Cadets were originally designed. You still had to put your foot on the brake pedal to return them to neutral. I think for this initial implementation, I think it's adequate to have friction on the two controls. You're not moving fast. I mean, I suppose you have a situation where someone passes out and slumps over the controls, and, you know, the tractor goes crazy. But that's a pretty far-fetched scenario, really. So I think it's going to be adequate to have friction controls. So this shaft will have to be constrained, and this sleeve as well will have to be constrained in a fashion that restricts the friction, restricts the handle operation with some friction, so it stays in whatever position you put it in. So this is what we're going to work on. I don't know how far we're going to get in this episode, but we'll get some progress made here, picking out the materials, figuring out where to place it within the frame. And we need to find a spot in the frame that is suitable for the operator to reach, and also provides access for these control arms to operate rods to the two trunnions. So, you know, that has to all be coordinated. So these rods will probably be 1/4 inch or 5/16, and we'll put a turnbuckle. My current thought is a turnbuckle in each one so that we can adjust the length of them slightly. We'll see. I may have to get some. My last attempt at putting left-hand threads on the end of a piece of 5/16 rod to put a turnbuckle on it. As with a turnbuckle, you need one left-hand thread and one right-hand thread. Was not too successful, so I have to determine whether I could probably buy left-hand threaded rod. I don't know what I'm going to do yet, so we'll see. There may be another way to have the length adjustment on this. Attaching it to the trunnion plate is another minor issue, because these plates are hardened steel, and you need to use a carbide bit to drill through them. I likely need to remove them, and they're held on by a SUR clip or a C clip on the shaft, the 5/8 inch shaft that holds them. There's a clip on the shaft. So they won't be they're not that difficult to remove. The access is a little tight, but it's doable. So removing the 2 trunnion plates may be necessary to drill holes in them to, connect them up, but we'll deal with that. Okay, that's the plan for the controls. We'll see how it goes. I need to tack on a few pieces to support the dash tower, so I'm going to do that now. I'm working on the seat riser. Need to prep the corners for the welds. All right, so that's the seat riser. All right, that gives us a good seating position with the dash here. Because there are slots in the casting for the front grille, that gives me some forward and back movement, you know, probably a ½ inch in each direction. So I tried to hit the middle of the range. That's just so you can adjust the engagement of the hood. So let's see real quick how it fits. I think that's pretty good to pretty close to the correct position. So there we've got the engine, hood, cowl, front grille, dash, everything pretty much in position. Only thing I haven't done is I haven't bolted the dash tower, so I need to do that. And we'll be basically done with the setup up here. We'll have to come back and build a fuel tank, which will sit under the hood here in front of the engine, and of course, you know, run all the controls for the engine and everything from the dash wiring harness, the throttle and choke cables and all the electrics. So that'll come later. All right, there's some minor adjustments I need to make to the I need to fasten this hood to the nose, pull it together. So I think that's It's getting real close. So finally. Okay. Let's talk some more about the hydro controls. The trunnion on the hydro has a movement of about 2 inches. All right, so that's important to know. We have movement of 2 inches, so we need to have a range of motion of the trunnion of 2 inches. And looking here, if we put the rotating shaft, I'm going to say it'll be mounted between these two cross members here. And if we go based on the center there, then we bring a lever up to the bottom of the dash. That's 16 inches. All right, so let's say our operating levers are 16 inches long, and we need to have 2 inches of movement, plus or minus 1 inch of movement at the control at the swash plate. So that translates to 2 inches of movement at the pivot point. If the operating levers are 16 inches long and we need approximately 1 inch of movement at the other end, we need to know how much movement we want at the top. So I'm going to say plus or minus 3 inches, say 6 inches of movement at the top. So 6 inches of movement at the top needs to translate to 2 inches of movement at the bottom. And so that's 1/3. If our operating levers are 16 inches long, then you need the control arms at the bottom of the pivot point to be 1/3. So if you want to convert 6 inches to 2 inches, it's proportional. So 1/3, roughly 5 inches long. So we'll need operating levers at the pivot point approximately 5 inches long. So what that translates to, if we go back to this diagram, if these are our operating levers and they're 16 inches long, then these arms at the bottom that the hydro linkages connect to need to be 5 inches long. And that'll give us 6 inches of movement at the top. Will translate to 2 inches of movement at the bottom. Close. I mean, it might be you need to go 5.3 inches, but we'll say 5 inches. We do have the radius of the pivot arm to consider as well. So, all right, that will get us part way to the solution for the levers. I do have some stock here. I have some tubing and some rod. The problem is it's too loose a fit. So this is 1/2 inch. This is probably 5/8 inch ID, or a little bit, yeah, I'm not sure. Anyway, it's too loose. So I need to order some stock which will be a close fit, the rod inside the tubing, or potentially 2 different pieces of tubing. Let me see if I have another piece of tubing over here that this would fit inside. Here's a piece. All right, that's too loose a fit as well. Okay, so I need to get some material that's be a closer fit for the control pivot. While I'm waiting for the materials to come for the hydro controls, I ordered last night from McMaster some heavy wall tubing that'll accept a 3/4 inch shaft inside with a close fit. So while that'll should come in 2 or 3 days, and that'll make it into the next episode. We'll fabricate that. While we're waiting for that, we'll finish up this episode with some plasma cutting. I've got the components for the tensioner assembly all modeled out in Fusion 360, and I've generated the G code, and I've put a plate of 1/4 inch steel on the table. I used my new jib crane or davit crane here. It's called a davit 500 from Oz Lifting Systems. This thing swings around. I can pick up a piece of sheet metal from my mobile rack, lay it on the floor, pick it up with an edge lifter, lay it on the floor, pick it up with a magnetic lifter flat, and then swing it around and set it, on the table. I do have another, if you're interested in this thing, I do have another video on the channel. If it's not published right now, it soon will be published, showing me installing this little crane. I think I'm waiting for the electric version of this winch. This is a neat winch. It has a brake built into it, so you can lower things slowly and in a controlled fashion. It has a lift rating of 500 pounds, which is more than I would ever expect to put on it. I think a 4x4 sheet of 3/8 is 275 pounds. So a ½ inch would still be under 500 pounds. I did lift a full sheet of 1/4 inch, which has got to be 2 1/4. No, I think the 3/8 inch 4x4 sheet is 375. So anyway, this should work for everything I need it. I do have an electric winch for this that's made for this coming. Once I get that and install it and run it, I'll finish that video and edit it and put it up. But when you're seeing this, it may or may not be up on the channel. But it works pretty well. So anyway, sidetrack. I do have a sheet of 1/4 inch on the table, and we'll cut out the components for the tensioner assembly. There's one other piece for the tensioner that's mounted to the frame, that's a spring retainer. But after I get these parts cut out, we look at them, then we'll wrap up this video and come back next time to work on the controls. I'll cut out, I suspect I'm going to cut out at least the actuator piece, the actuator arms for the control, the lower shorter arms. I'll probably cut out of this material. The levers themselves, I think, are going to be tubing, maybe ½ inch or 5/8 inch diameter tubing, and I'll put some hand grips on the top of them. Okay, well, let's play a little bit with the plasma table and see how the tensioner assembly turns out. This will be my first time cutting 1/4 inch material. I had good success. If you look at the previous video, I cut out some 3/16, and it worked great. So expecting this to work as well. All right, I do have to fill the table. I'll show you what I do for that. I just have a switch here, a sprayer tank full of the water for the table, and you can see the output goes into both sides of the table and fills the table. So it'll take a few minutes to fill the table, and we'll come back when we're actually doing some cutting. Okay. I've got the plasma table set up with the fire control software and my parts. This is the cut path here. the two sides of the tensioner, the plate that goes between them, the base plate, and the two sides of the support, pivot support. I just did a few test cuts, and I don't mean to spend a whole lot of time on the plasma table, but I did a couple test cuts here since this is the first time I've cut 1/4 inch to determine the best feed rate. I think the best feed rate is 40 inches per minute, which is the same as I used on the 3/16. My program is set up for 35, and 35 works okay too. Not much difference between the 35 and the 40. So I'm going to run it at 35. All right, that seemed to go fine. I noticed that I may need to increase the pierce delay. I had pierce delay of 1 second. I might need to be, 1.2 seconds or something like that. But it looks like, see if I can get one of these pieces out of here. It's got a nice edge finish. There's a little bit of dross on the back, but not too much. So I think it worked fine. All right, well, I'll touch them up with the sanding disc and we'll look at how they go together. Okay, the way these parts go together. That goes between those two. Put a couple little magnets here. Something like that. And then All right, it looks like I cut that piece too small. It's supposed to go between these two. All right, so I need to cut a different piece, but the way it works is this bracket bolts to the, or is welded to the frame. This is the pivot arm. The idler pulley goes on in here. Actually, that goes down further. So there's an idler pulley here, and this pivots on a bolt which goes across here, and the idler pulley here then presses into the belt. So that's the idea. Obviously made a mistake here and cut that the wrong size. So I'll go cut a different piece from that. That's what it's supposed to look like. We'll assemble and begin installing this in the next episode. Okay, that wraps up this episode of the Dozer build. I've got some progress on the tensioner with the parts cut out. We'll assemble those and begin the installation process there. I need to machine the idler pulleys. There's a pair of pulleys, but I need to machine a flange off of them to use them. So we'll do that, begin work on installing the tensioner. I will hopefully have the material to start assembling the control mechanism. So those are the two things on tap. Meanwhile, I'm going to design a track pad. Perhaps in the next episode, we'll cut out a couple track pads and look at the track design, mock up a track using the conveyor chain. And then once I'm satisfied that the conveyor chain is going to work, I'll order the second drive sprocket. By then we should have the spacers for the hubs. We can start shifting our focus from the main frame, operator, accommodations to the track and the track frame. Got some ideas for the idler pulleys and idler sprockets or wheels, and for the bogies. They have to be pretty rugged because they support, most of the weight of the Dozer. So, all right, that's it for this time. Thanks for watching. I appreciate all the comments. If you're new to the channel, welcome. If you've been around for a while, thanks for sticking with me. I appreciate it. A thumbs up and a comment would be great. I enjoy reading the comments. And if you haven't already subscribed, please subscribe so that you don't miss upcoming episodes. We're in this for the long haul, so hopefully this will provide some entertainment for your weekend viewing pleasure for a couple of more months. It's a big project. Thanks for watching. We'll see you guys next time.